Great, so now we're going to go over the homework solutions for the buffer problems that I assigned on the back of the book. This will not be a very long video as the problems I assigned are fairly easy. So let's get started. So I assigned you problem number 1, which says calculate the pH of a solution that is 0.05 molar in acetic acid, CH3COOH, and 0.05 molar in sodium acetate, which is the conjugate base. So if you look at the table that's in the chapter that has the pKa's of different weak acids, you will find that acetic acid its pKa is equal to 4.75. So we are, and then the conjugate base of this would be minus the hydrogen, add a sodium there, so it would be sodium acetate. So to find the pH of a solution that is equal in concentrations, if you recall the formula we had, that pH is equal to the pKa plus the log over with the concentration of the conjugate base on top and the acid on the bottom. So in this case, because we have the same number on top and bottom, right, we're starting with equal amounts of base and acid. Well, if you go to your calculator and you take the log of, first of all, a number divided by itself is 1. Okay, so that this ratio here is going to be 1. And if you go ahead and take the log on your calculator of 1, you will find that the log of 1 is equal to 0. So that's the same, the pH is saying that it's equal to the pKa plus 0, which means in this particular case, the pH is equal to the pKa. So the pH of this solution would be 4.75. All right, number 2. Calculate the pH of a solution of the same species. So we're going to have acetic acid and sodium acetate again, but this time we have different concentrations. So we have our acid, we have a concentration of 0.10 molar, and then our concentration of our conjugate base is going to be 0.20 molar. And again, the pKa for this is going to be 4.75. So now all we do is plug this information into our equation that we had. So the pH is equal to the pKa plus the log of 0.2 over 0.1. Now, if we take that in our and type that in our calculator, we would have 4.75 plus the log of 2. And the answer would be 5.05, and that would be the pH. Now I said the log of 2 because 0.2 divided by 0.1 is the same as taking 0.2 and multiplying it by 10, so we're taking the log of 2. So 4.75 plus the log of 2 is 5.05. So that would be our pH for that solution of acetic acid and its conjugate base. Okay, so the next one I assigned you 21.9. It says find the pH of a solution that is made when we take 2.16 grams of propanoic acid, and it gives you the formula there, and 0.56 grams of NaOH. So I'm going to put this as POH. Man, these lines, I tell you. And then we have, how many grams? Okay, 0.56 grams of NaOH. Okay, so the POH is going to be the acid in this case. Okay, so first thing we need to do is find out what the actual the molar mass of these species. So, or how many moles we have. So we do that by dividing by the molar mass, because it gives us the chemical formula for the propanoic acid. We can just add that up. It has 3 carbons, so 3 times 12, 0.01, plus 6 hydrogens, 6 times 1.01, plus 2 oxygens, which is 2 times 16. So the molar mass of propanoic acid is 74.09 grams per 1 mole. And then the molar mass of sodium hydroxide is 22.99 plus 16 plus 1.01, and we get 40 grams. So now to find the number of moles, we just multiply this through. So 2.16 grams divided by 74.09 grams is going to be 0.029 moles. And then for sodium hydroxide, we have 0.56 grams divided by 40 grams. And we're going to have 0.014 moles. Okay, so now we're taking these and we're these number of moles here of each of these species and dissolving it into 100 milliliters of solution. So remember, the formula for molarity is going to be the number of moles over the volume, so in liters. So we can just divide these two numbers by 0.1, because that's how many liters that we are putting it into, which would be 0.29 and 0.14. Now these are our new concentrations. So now we're ready to find what the pH of the solution is going to be. So we're given the pKa as 4.87. So the pH is equal to 4.87 plus the log, and we're going to have 0.14 moles of base, and we're going to have 0.29 moles of acid. Now I want to point something out here that I didn't say yet, and that's important, is you may notice that this is a strong base and we're titrating it into a weak acid. You can do this to make a buffer, because whenever we put a strong base in, that strong base is going to deprotonate some of that weak acid, and then the product from that reaction is going to be the conjugate base. So therefore the number of moles of strong acid is going to directly correlate to the number of moles of conjugate base that we're going to end up with. So now we're ready to punch this in our calculator. So we got 4.87 plus the log of 0.14 divided by 0.29. And we find we have 4.55. And that's our pH. And that is the answer for number 9.